Linear equations in one variable. Okay, so our objective for this video lecture, we want to solve linear equations in one variable, both algebraically and graphically. So first things first, what exactly is a linear equation? Well, the linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. If a is equal to 0, you have no x term because 0 times x is 0, and you're just dealing with a constant, so it can't be a linear equation in one variable because you won't have that variable. So a cannot be 0. A linear equation is also called a first degree equation because the degree of x, which is, in other words, x's exponent, is 1. So we look up here, even though there is no exponent written, we know that every number has an exponent, or every variable or term has an exponent, and that's 1. We just don't write it. So we could rewrite this as a times x to the first power plus b equals 0, and there is your first degree. The highest degree of the exponent is 1, so it is a first degree equation. Excuse me. So let's talk about how to solve a linear equation algebraically, and I'll shift my paper up here for you so we can see it. Okay, now note, you might not need to use all of these steps every time, but this is the general way you want to solve a linear equation algebraically. We're going to simplify, separate, and solve, and then we always check. Equations are always checkable. You should never wonder, is my answer correct? Because you can always check to see. You can question why your answer is not correct, but there should never be a question that says, am I right? Because you can check and see if you're right or not. So step 1, again, as necessary, simplify. Simplify, whoops, I think I put simply here. Let's rewrite that as simplify the algebraic expression on each side by removing the grouping symbols. In other words, applying the distributive property and or combining like terms, which is often abbreviated CLT. Step 2, we're going to separate. We want our variable terms on one side and our numerical terms on the other side of the equal sign. We want to keep our variable terms separated from our numerical terms. We want to do that. And then finally, step 3 is to solve. And normally this is just multiplying or dividing each side of the equation by the same thing. We're solving for the unknown. And as I said earlier, step 4, whenever you're dealing with an equation, when you're dealing with an inequality, you always want to check your solution using the original equation to determine whether or not you have the right answer. Okay, let's do some problems. Take a look at this with 3 examples. All right, example 1 here. Solve 4x plus 5 equals 2x plus 29. All right, step 1, simplify each side as necessary. We'll notice the left side is a variable term and a constant term. There's nothing that can be combined. There's no terms that can be combined. There's no distributing. There's no grouping symbols to remove. And the same thing can be said about the right side. You have a 2x term and a positive 29 constant term. So this is as simple as it gets. Okay, so step 2, now let us separate. We want our variable terms on one side and our constant terms on the other, on opposite sides of the equal sign. My suggestion is to always start with the variable term and keep it positive, because people lose negatives. So if I were to move my 4x from the left to the right, I would have negative 2x's on the right, and I prefer to keep those x terms positive because I might lose that negative. So instead, I'm going to choose to move the variable terms to the left, because this way my variable term 4x minus 2x is a positive 2x, and I'm not dealing with a negative when I go to the next step. Again, people lose negatives, so work hard to keep positives. Okay, so I have 2x plus 5 is equal to 29. Again, 2x minus 2x is 0. Now I'm going to, because I brought my variable term to the left, I'm going to move my number terms all to the right of the equal sign. And at plus 5, I'll do that with the inverse operation subtraction. I'll subtract 5 from both sides. And I have 2x is equal to 24. Now I have separated, again, variable terms in this problem are on the left. Numerical terms or constant terms are on the right. They've been separated. Now let's just solve. Solve for x by dividing both sides by 2. And I think the answer is 12. Okay? Remember, don't stop. Okay? You want to know, am I right or not? It's not a question of, is this correct? We can find out. We can check it to see if it's correct. Okay, so let's do our check. I'll do my check over here. Okay, here's the original equation. So I want to replace x, substitute what we think x is in for x wherever we see it, and I use parentheses. Okay, is this equal to, is 4 times x, which is 12, plus 5 equal to 2 times x, which is 12, plus 29. Is this a true statement? If it's not a true statement, then my answer is wrong, and I did something wrong in my math here. Let's see, we could pull out a calculator and check this. We could do this mentally if you're good at that. 4 times 12 is 48. 48 plus 5 is 53. 2 times 12 is 24. 24 plus 29 is also 53. Check. Okay, I feel good about my answer because I put it back into the original equation and it made a true statement. All right, that's algebraically. Let's solve these things graphically. Let's solve this equation graphically. Graphically, what you want to do is set the left side equal to y1. So let's have y1 equal 4x plus 5. And let's have y2, we're going to be using our TI-84, is equal to 2x plus 29. Okay, so we're going to set y equal to the left and y equal to the right. And these are two lines, so the question is, where do they cross? At what x value do they cross? Okay, so at what x value do these lines intersect? That's how you solve this graphically. Okay, and we think it should be at x equals 12. Okay, that's where they should be intersecting when x equals 12. So let's put these into our graphing calculator. I'll slide this over. I think you can still see it. And I'll come into here, and I think I've got everything. All right, I'll go like that. Okay, so my graphing calculator. Okay, I'll go into my y equals button, top left here, and y1 is 4x plus 5. And that's a line. If I go to, I always press zoom and go to standard, which is number 6 here. And you can see there's 4x plus 5 right there. Okay, so that's our blue line. Let's go to y and put in a y2, 2x plus 29, 2x plus 29, and I'll graph. Now there's, that's over here. Okay, maybe I made a mistake someplace. Let's see, look back at my y equals 4x plus 5, 2x plus 29, okay. So I can't see where they cross, so I'm going to need to zoom out a little bit. So I'm going to go to my window. I know I need my x be 12. Well, this goes to 10. So my window should go to, let's go to at least 15, and I'll count, I'll do my tick marks by 5. So there's my 4x plus 5, and again, I'm over here still, so I'm way over. I need to go up higher. Looks like they intersect up a lot higher. So I'll go back to my window. I need my y. Let's go from -10. Let's go to 60. And I'll scale my y by tens. So there's my first line. Oh, here we go. Now I can see where they intersect. Okay, they're intersecting here in quadrant 1, right up here in the top corner of my window here in quadrant 1. And all we need to do now is calculate that intersection point. So second calc, number 5 is the intersect. And I normally put the cursor kind of close to the intersection. Okay, so you have to mark your first curve close to the intersection, press enter. Mark the second curve, which is the red one, close to the intersection, press enter. And then it says take a guess. Yes, please do that. Well, here you are at x equals 12 right there. So we intersect at 12. And there's our 53, which we came up with here. Okay, it intersects when x is 12. These two lines have the same y value. That is the solution to this equation. Okay, let's take a look at a second example. A little bit more involved. Solve 3 times the quantity x minus 2 plus x is equal to 5 times the quantity x minus 1. Well, both of these sides, the left and the right, can be simplified. There's a lot going on. These expressions, we can do some multiplication or some distributing, and we can do some combining of like terms. So I'm going to distribute on the left. 3 times x is 3x. 3 times -2 is -6 plus x. And I'm going to do some distributing on the right. 5 times x is 5x. 5 times -1 is -5. Okay, the right side looks pretty simple. Left side, though, I have 2 x terms. 3x's here and 1x here, so I can combine like terms on the left side. And I have 4x minus 6 on the left is equal to 5x minus 5. So there you have it. I have now simplified, that's step 1. I have simplified this equation. Now I'm going to separate. Okay, again, taking a look here, I always start with the variable term. I want to keep it positive. If I move my 4x's to this side by subtracting 4x's from both sides, I have a positive x on the right. If I subtract 5x's from both sides, I have a negative x on the left. Not a fan. I'm a fan of keeping my x terms positive, so I'm going to subtract 4x's from both sides. On the left side, I have a -6. On the right side, I have an x minus 5. Since I've decided to put my variable term or my x term on the right, I need my numerical term or my constant term to move to the left. So I'll add 5 to both sides. And I have x equals -6 plus 5 is -1. And you'll notice there's no reason to solve, it's done. There's no step 3 in this case. The separation resulted in the solution, x equals -1. Okay, let's do a check. Okay, I'll continue my check down below here. Okay, again, the question is not, am I right? No, you check to see if you're right or not. So let's check it to see if indeed the answer is x equals -1, if -1 makes this equation true. Okay, so I use parentheses, so the original equation is right up here. 3 times parentheses, I put -1 in parentheses, minus 2, okay, plus -1, so I replace the x here and here with what I think the answer is. Does this equal, that's a question, 5 times -1 minus 1. Okay, is that true? Well, let's say what, let's just use our calculator. We can use our calculator to do the math. I'll slide this up. I'll just pop in the left side and see what it comes out to be. Get out of my graphing mode. So I'm just going to copy what the left side says here. So 3, parenthesis, parenthesis, -1, close parenthesis, minus 2, close parenthesis, plus parenthesis, -1, close parenthesis. I just copied the left side into my calculator. I press enter. Left side is -10. Okay, thank you, calculator. What's the right side? Okay, right side. 5, open parenthesis, negative 1, close parenthesis, minus 1, close parenthesis, enter. I got the same thing. I got negative 10. Terrific. All right, looks like I've got the correct answer of x equals negative 1. That worked out just fine, okay? So now let's take a look at this graphically. Graphically, if we set y1 equal to the left and y2 equal to the right, where they intersect is the solution. So let's do it graphically. Okay, we're going to have y1 equal to the left side. I'm just going to copy it. 3 times x minus 2 plus x. We're going to have y2 equal to the right side. 5 times x minus 1. And let's see where they intersect. Those are two linear equations. First degree, they're going to be lines. So let's go into here, y equals. I'm going to clear out what I had from the previous problem. Okay, so y1 is here. 3 parenthesis x minus 2, close, parenthesis, plus x. And y2 is this equation, 5 parenthesis x minus 1. I always start with that standard window. I'm going to go to zoom standard, which is a negative 10 to 10 in both the x-axis and the y-axis. Okay, let's see. There's our first line. And there's our second line. Okay, so it looks like they, obviously it looks like down in here is where they're intersecting. That's, let's see, quadrant 1, quadrant 2. This is quadrant 3. It looks like they're in quadrant 3 down here. So let's zoom in a little bit on quadrant 3. I'll go to my window. Let's see here. I'll do x. I'll go negative 15 to 5. And I'll go from y from negative 15 to also to 5. Let's try that. Okay, so now I'm in the third quadrant a bit better. There's my first one. Here comes my, okay, so they're intersecting right around here, it appears. So let's do a intersect. So second calc. Number 5 is the intersection point. You can just press the 5. Again, I like to kind of come in and see my cursor near where I think they're intersecting. There's my cursor. So that's on curve 1 because it's in blue. Enter. Curve 2 is in red. Enter. Take a guess. Enter again. And it says at negative 1. They intersect at x equals negative 1, which right up here you can see on the screen with my pencil is what the answer we got. X equals negative 1. And when x equals negative 1, both sides equal negative 10, which we can see right here we got. So that's our solution graphically. All right, one more example. Let's take a look at this one, which looks like it's might not be linear. Okay, so we can see here we want to solve the quantity x plus 2 times the quantity x minus 4 equals the quantity x plus 3 squared. Now wait a second, it looks like if we simplify we're going to wind up with squared terms, and that's not linear. So let's take a look at what we can do with this. So first off, let's simplify, let's multiply both sides. Okay, well I'll tell you what, first off, well I'll do this. Let's multiply this side, so we do the x times x is x squared. X times negative 4 is negative 4x. And I'm going to come down a line because I want to do one more thing. So I have x squared minus 4x. And now I distributed it to the x. Now let's distribute it to positive 2. So plus 2x minus 8 equals. Okay, I recommend, students will mess this up. I recommend you first, let's expand this. X plus 3 squared means x plus 3 times x plus 3. Now let's multiply so we make sure we don't lose that middle term. we can combine like terms on the right. I have two x terms here, so the left side is x squared minus 2x minus 8. Now let's multiply the right side. Okay, this is x times x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Okay, left side is simplified. I can't combine anything else. This is a squared term. This is a linear term. Remember, there's a 1 here. This is a constant term. And this side is x squared plus, I can combine like terms here. I have 6x plus 9. Now this looks like it's not linear, but wait a second. If you'll notice, I can subtract x squareds from each side, and the x squareds disappear. I wind up with negative 2x minus 8 on the left is equal to 6x plus 9 on the right. And I do have a linear equation. Okay, I don't have any squared terms to worry about, so I can do what we're familiar with. All of this, everything here we've done so far is simplifying. Now let's separate. Again, if I subtract my 6x's from both sides, I wind up with a negative x term. I'm not a fan, so I'd rather keep my x terms positive by adding 2x's to both sides. And this is going to be 8x plus 9. Okay, and now I'm going to subtract. I'm going to move my constant term, my number term, to the left by subtracting 9 from both sides. Okay, and I have 8x is equal to negative 17. Now I'm going to solve. I've done step 2, separate. Now I'm going to solve. And I come up with x is equal to negative 17/8. I'll just leave it. I like to leave things as fractions as opposed to mixed numbers. Looks like the answer is negative 17/8. Huh. Well, I'll tell you what. Let's check this one graphically. So first off, graphically, I'm going to need to know what is negative 17/8 as a decimal. Okay, so let's go to here. Negative 17 divided by 8. Okay, so this is equal to negative 2.125. Okay, so I know that's the decimal equivalent. So now let's go ahead and let's do. So I'm checking this one graphically instead. Okay, we know y1 is equal to the left side. I'm just going to write it just as it is, x plus 2 times x minus 4. I'll set y2 equal to the right side. Again, just write it as it is, x plus 3 squared. And now let's see if they intersect at negative 2.125. The x value, negative 2.125. So put that up here. Okay, back to here, clear out the previous problem. This one is going to be x plus 2 times x minus 4, that's y1. And this one's going to be x plus 3 squared, the quantity, so x plus 3 squared. And now I'll go back and do my Zoom standard 6, and here they come. There's the first one. It makes a curve, that's okay. The second one, okay. Intersect right here, it looks like, in quadrant number 2. So let's go to second calc, the intersect, number 5. Again, I move my cursor over close to the intersection. That's pretty close on the first curve, y1. Second curve is right there in red, y2. Guess, and sure enough, negative 2.125 comes up right there, and that's what we have right up here, negative 2.125, which as a fraction is negative 17/8. You'll notice you won't get the fraction here. You get a decimal, and sometimes that can be an approximation, so we need to be careful with that. But we can see that we just checked our answer with those two, and we got negative 2.125, which is the same as negative 17/8. So there you have it. How to solve linear equations in one variable, both algebraically and graphically.